Okay, shit. Okay. Good day, everyone. I hope everybody is well this day. My name is Tsepo Maifo, and today I'm going to do Euclidean Geometry, grade 11, grade 12. I'm going to do Theorem 5 and Theorem 6, Theorem 7 and Theorem 8. So, before we continue, you can like, comment, share, and subscribe to my channel, and then you will see all the wonderful equations, wonderful questions that you want to ask, then I will answer you. So, today, this is what we are going to do. This is Theorem 5. Theorem 5, whereby it talks about if the opposite, let me say the opposite or let me say the sum of opposite angles in a cyclic quadrilateral. In a cyclic quadrilateral are supplementary. So, when we say the sum of opposite angles in a cyclic quadrilateral are supplementary. Supplementary means they add up to 180. That's a supplementary. And then, when we speak of quadrilateral, then we speak about a shape with 4 sides. That is a quadrilateral. And then when we say cyclic, we mean this is a circle. Okay? So before I continue with the theorem, when we speak about a cyclic quad, we simply mean inside the circle there must be a quadrilateral. Do you get? Note this. A theorem can never be a cyclic quad if all 4 points they don't touch the circumference. Do you get it? All the 4 points must touch the circumference. Do you get it? And then we have the center of a circle here. So let's say we have A, we have B, we have C, we have D. Do you get it? And then when we say the sum of opposite angles, these are opposite angles. These are opposite angles. It means that A plus C is equals to 180. And angle B plus angle D are equals to 180. This is what we are given according to Theorem 5. Here we talk about cyclic quads, whereby all 4 points, all 4 corners must touch the circumference. But if one doesn't touch the circumference, just know that it is not a cyclic quad. For it to be a cyclic quad, it is because of it must touch the circumference at all sides, isn't it? They are subtended by the same arc. This is an arc. This is an arc. This is an arc. This is an arc. And then we go again to Theorem 6. Whereby it says an opposite interior angle of a cyclic quadrilateral is equal to an exterior angle of a cyclic quadrilateral. So what do we mean by this? All these angles are interior. These are interior angles. And then here I have a circle. Here I have a quadrilateral. We have A, we have B, we have C, we have D, isn't it? And then, what do we have? And remember, let me prove this using a theorem of Piper, using theorem 5. So when we say an exterior angle of the cyclic quad, it must be determined by a secant, isn't it? Therefore, it tells you that this angle is equal to that angle. Let's say this is D1, this is D2. Okay? How to prove this? Remember that we are going to use theorem 5 to prove theorem 6. And then if you separate the two, remember that we have a straight line. That straight line, it is equal to 180 degrees. If you can check again, in this 180, we have D1, we have D2. And then from this cyclic quad, we are going to use theorem 5, whereby we are going to say A. Remember that the sum of these two are supplementary. A plus angle D, which D1, is equal to 180 degrees. Why? Because of it is opposite angles of a cyclic quad. That will be your reason. And then you come back again. What do you do? In this straight line, we have D1 d1 and d2. The sum of d1 and d2 are equals to 180. Reason being angles in a straight line. Isn't it? Therefore, from this equation, what do? Remember, we have d1 and we have d1. It means that we can make d1 both sides the subject of the formula. It means that you say d1 is equals to 180 degrees minus d2. That is your equation 1. And then you come here again, and you are going to make d1 the subject of the formula. Therefore, you are going to say d1 is equals to 180 degrees minus a. Because now when you transpose, the sign changes. And then this is your equation 2. Do you get? So I'm going to do a simultaneous equation to prove this theorem. Therefore, we are going to equate 1 and 2. Equation 1 and 2. So what does it tell us? It tells that we are going to say 180 degrees minus d2, isn't it? Is equals to 180 degrees minus a. Do you get it? And then if you transpose one of the two, whether you take this 180 to the right or you take this 180 to the left, they will eliminate each other, because it's going to be 180 minus 180 minus d2 is equals to negative a. Do you get it? So it tells us that 180 minus 180 is 0, minus d it is minus d2 is equals to minus a. And then what we can do, it's up to you whether you can divide by negative 1 or you can simply do this. Transpose, exchange the terms. A must come on your left and D must come to your right. Therefore, it tells you that angle A is equals to D2. Do you get it? This is what this theorem tells us, that an opposite interior. This is an interior. This is an exterior. An opposite interior angle of a cyclic quad. Cyclic because of all 4 points, they touch the circle. An opposite interior angle of a cyclic quad is equal to an exterior angle of a cyclic quad. Okay? Let's hope that everybody had Theorem 5, Theorem 6, and let us see each other on the next session. Let us hope that you enjoy, and if you have any questions, you can send the question papers to me, and then I'll be able to answer you. Shalom.